Good morning, students. In the previous class, we have read up till the connection of battery. Again, a recapitulation today we'll do. What is the definition of battery? Battery may be defined as a group of cells joined in series, like positive, negative. Then again, cells positive is joined with the negative terminal, and it goes on like that. Now, what are the effects of electric current? First is heating effect, next is magnetic effect, then is chemical effect. Now, what is heating effect of electric current? When an electric current is passed through a high resistance wire like nichrome, the wire becomes hot and produces heat, as we see in heaters, like very often sometimes we use heater in for cooking purpose also. Those heater, you will be able to view the actual representation of the nichrome wire. So how when we switch on the plug, the wire gets heated up, so much heated up that it glows, it becomes red, right? So that way we will be able to visualize the heating effect of electric current. Next point is amount of heat produced depends on resistance of the wire, and secondly magnitude of current passing through the wire. It's quite obvious, if the resistivity of the wire is very high, then heat will be higher, and also it is depending upon the magnitude of current passing through the wire. One point is also to be noted, that is, a short wire has less resistance, whereas a long wire has more resistance, and a thick wire has less resistance, whereas a thin wire has more resistance. So, what I am trying to tell you, that if the length of the wire is very short, then its resistance is less, and if the length of the wire is very long, then it has more resistance, and it also depends on the thickness of the wire. If the wire is very thick, then it will be having less resistance, and if it's very thin wire, then it will be having more resistance. So these are the some of the points which we should keep in our mind. So here, that point only I have given, that is, short wire has less resistance and long wire has more resistance, thick wire has less resistance, and thin wire has more resistance. Now let's see the applications of heating effect of current. So heating effect of electric current is utilized in the working of electrical heating appliances such as electric room heater, electric iron, electric kettle, electric toaster, electric oven, water heater, immersion rod, etc. It is also used in electric bulbs for producing light. The heating effect of electric current is utilized in a safety device called electric fuse for protecting the household wiring and electrical appliances from accidental large flow of current. At our household means connections, if there is no fuse present, then definitely there will be a disaster anytime, because voltage may be up down, may happen. So it is checked by the fuse. If anything will happen, it will be on the fuse only, no harm will be on the other appliances. And the coil present in the of high resistance wire which is present in the electric heating appliance is nichrome. So it just now we have read that it has very high resistivity, so it gets heated up, and negligible heat is produced in the connecting wires because it is made up of copper which has very low resistance. That's it. Now let's see the electric bulb. So electric bulb is having thin tungsten filament. So sometimes when the circuit is on, sometimes the bulb doesn't glow. Why it's happened so? Because sometimes the filament is not working. Why it is happening? Let's see. Electric bulb which we use for producing light works on the heating effect, and the filament gets heated due to high temperature, right? So it starts glowing. Actually, the filament becomes white hot and emits light, and lot of electricity is consumed by the filament of an electric bulb appears as heat. So when the circuit is on, right, when the electric current passes through very thin high resistance filament, as resistance is high, so it gets heated up, and as it gets heated up, so it gives us light. So electrical energy is converted into heat energy, which is finally converted into light energy. So I think up to this much everything is clear. Fine. So we should not touch a hot electric bulb, otherwise our hands may get burned up. Next is this heating up of bulbs are not at all desirable because it is actually wastage of energy, right? So a major part of the electricity is getting converted to heat. Only a small part is using for its light. So this is not at all desirable. So nowadays, what we are using is CFLs, that is compact fluorescent lamps. Fluorescent lamps we are using. Why we are using it? To reduce or to discard the huge wastage of energy which earlier was happening in electric bulbs. Why it was happening? Because huge amount of current or electricity was getting used up in heating, and very less was used up in lighting the bulb, which is not at all desirable. That's why came the fluorescent tube lights and compact fluorescent lamps, which do not work on the heating effect of current. So here you can see how the CFL is working. CFL means compact fluorescent lights and fluorescent tube lights. Right. So CFL and fluorescent tube lights do not have filament. They don't have any filament. So there is no heating effect. So how they work? Fluorescent tube light contain mercury vapor and inside is coated with phosphor. Right. So inside is coated with phosphor. That's I have written in this way flowchart I have given that circuit is switched on, the current passes through the fluorescent tube, and then the mercury vapor emits invisible radiations, and phosphorus absorbs these radiations and glows. So this is the mechanism behind the CFLs and fluorescent tube lights. Again I am repeating, the circuit is switched on, current passes through the fluorescent tube, Mercury vapor emits invisible radiations, but you can mention UV radiations. Invisible UV radiations or ultraviolet radiations. Phosphorus absorbs these radiations and it glows. That's it. That's why there is no heating effect and the bulb or tube light glows. As the current passes through the fluorescent tube, the mercury which is present inside the tube emits invisible UV radiations, and phosphorus which is means there means coating is there, that phosphorus absorbs these UV radiations and it glows. That's why we can see without any heating effect also fluorescent tube light and CFLs glow, and there is no wastage of energy which was present in earlier bulbs which were having filament, tungsten filament. I hope this much is clear to all of you. And yes, these points you should always keep in mind, like short wire has less resistance, long wire has more resistance, and thick wire has less resistance, and thin wire has more resistance. Electric fuse. It is a safety device which prevents electric fires. And damage to. Now, what is electric fuse? It is a safety device which prevents electric fires and damage to electrical appliances due to excessive flow of current. Various time it often happens like voltage may be up and may be down. When it's high voltage, huge voltage is coming, there are severe chance that the circuit may get fire or may damage. To prevent this, fuse is there which acts as a safety device and it nullifies the effect, means it takes all the effects on itself. It works on the heating effect of current. It consists of a short length of thin tin plated copper wire having low melting point. The thin wire has high resistance than the rest of the electric wiring in the house, so whenever the current is suddenly increases, the thin wire fuse gets heated so much that it melts and breaks the circuit. Right? So what a fuse comprises of thin wire. And whenever there is high current is coming, that times what happens? It gets heated up as the wire is very thin and it gets melted and the circuit breaks. This prevents fire in the household as well as damage also. When a fuse gets blown, a new fuse has to be fitted in place to restore the electricity. Obvious, it's quite obvious because when the circuit is broken, it can't work, right? So what we need to do, we need to replace it with a new fuse. Now let's see what are the causes of large current flow, that is short circuit and overloading. So basically, there are two causes of large current flow. One is short circuit and another is overloading. And in our household means there are two insulating wires. Household electric wiring, what we have, two insulated wires. What are those insulated wires? Live wire and neutral wire. And very often it happens, means very often means sometimes it may happen, like the plastic insulation of the live wire and the neutral wire may be broken or tear off, and they may accidentally touch each other. The two naked wires touch each other. What will happen then? Then the touching of live wire and neutral wire will result into short circuit. It will make large current to flow through the household wiring, and huge damage may happen to the appliances and all other electrical appliances and other things. So this is to be avoided, and we should always check the wirings that this may not happen. Next is overloading. The name itself is justifying the definition. That is overloading, when excessive load we put on. How it's happening? When too many electrical appliances are connected into a single socket. Because see, the voltage is coming, and if I in the plug point, if I make the extension cord, and so many sockets are there, and if I start using high, means those electrical appliances which require high voltage, that means it is having so much burden on it. You think in that way, it is having so much burden on it, so what it will result in? Overloading. So when a house or some other building is wired, the wiring is protected by fuses, and when a short circuit or overloading occurs, the fuse wire blows and the electric supply is broken over there. This prevents the electric fires. And when the overloading is there are also huge chances that there may catch the fire, or some other things may happen. It will damage the electrical appliances. Main thing is that. So we should not do it. That is not at all desirable, right? Next is MCB. MCB can also be used in place of fuse. So MCB stands for miniature circuit breaker. Very often, whenever the electrical board is opened, you can see that MCB is there. Sometimes the voltage gets up and down, means, so it will be controlled by MCB, miniature circuit breaker, right? So these things are there. Electric fuse is there and MCB is there. Anyone can be used nowadays. Most of the household circuits are using MCB, that is miniature circuit breaker, but both the functions are same, electric fuse as well as MCB. That is MCB also breaks the circuit, but the mechanism is different. Definitely, like electric fuse works on the heating effect, that the it's get heated up and the thin wire gets melted and the circuit is broken, but MCB works on the magnetic effect of current. Now let's see what it is. So MCB is like a special kind of electric switch which automatically turns off when the current circuit becomes too means large, and cuts off the electric supply. Current in the circuit becomes too large. Whenever there is huge current is flowing, it will automatically switch off, and it can be reset in the on position when the fault is restored. So it has a huge advantage over electric fuse. If electric fuse is there, then it is to be replaced, but MCB need not to be replaced. Only it gets off state, and whenever the fault is restored, we can put it at on stage. So it need not be replaced, right? So this is the thing. Now in the next class, we'll see about the magnetic effect of electric current. That's all for this class. Bye students. Hope you have enjoyed the topics which I have covered today. If you like, then please press the like button and do subscribe this channel. Thank you. Bye.